Hi everybody, welcome to Groundwork, a new podcast from McLanahan Corporation to talk about key material processing topics, from agriculture to mining to material recycling. We'll discuss the best ways to process the raw materials that power the world, because if it's not growing, it's mined. My name is Neil Mullan. I am Director of Sales for C&D Recycling in North America. I have about 20 years experience, whether it's natural sand and gravel, hard rock, and or construction demolition waste. So happy to be here, start off our podcast series, and I have my special guest today, Donal McNicholl.
Hi, listen, Neil, thanks for having me. My name's Donal McNicholl. I'm a Director of Sales for McLanahan UK Aggregate Systems Group. So I handle all the commercial activity in that region, including Ireland, specifically tailored towards quarries, sand and gravel pits, and then recycling centres. So I've been in this industry now for, God, it's coming up 20 years. Every time I go to the hairdressers, my hair is getting more grey. But there's a few guys now reporting to me in McLanahan 2.5 years. Spent most of my time since university working for OEMs, original equipment manufacturers tailored towards quarrying, but I actually worked for a producer for 5 years as well. They had 2 gritstone quarries, a couple of basalt quarries, and then we handled seals from the North Landfill site. So I've got a fair bit of knowledge from a producer side. So hey, listen, delighted to be here, man, and hopefully this goes okay.
Thank you. So the topic today, we're going to discuss how is C&D recycled aggregates made. And for anyone who doesn't know what C&D stands for, it's construction and demolition waste. So waste that's generated from construction of buildings, demolitions of buildings or roadways. Generally, it's turning a material that's aggregate based, which is considered a waste, typically would go to landfill, and processing that material so that it has it's repurposed. It can be used again for construction purposes. So that's what C&D. I also call C&D challenging and deleterious when I'm trying to describe what we do, because the material it's really difficult to process, and you have to really put in a lot of time and thought into how you design your systems to deal with that. So, so Donal, we cover different markets. You're based in the UK and Europe. I'm in North America. Obviously, C&D Recycle, it's huge over in your territory. So do you want to just tell us a little bit more about the market over there and the importance of C&D Recycle?
If you look, the UK is it's different. The whole of UK and Europe is completely different than North America, because we're the situation where in certain countries we don't have a huge amount of natural resources. So then what that's led, it's led to the burgeoning economy of recycled aggregate. So if you take a primary aggregate, which is a naturally occurring mineral, so either a crushed rock, a sand and gravel, that performs a certain function in our region. And then you've got recycled aggregates, which is basically you're taking in a waste from a construction site, reprocessing that, and then selling that back out into the marketplace as a secondary aggregate or a recycled aggregate. Then we've got a third piece, which is a secondary aggregate, which is basically the product that's derived from another industrial resource. So maybe China clay mines or blast furnace slag, that kind of topic. So we kind of had to go that route, Neil. If you take the MPA, which is basically the Mineral Products Association in the UK, they report on all the aggregate total sales in the marketplace. Last year, there was maybe 269 million tons of natural aggregate sold in our marketplace, and 70 million tons of those were recycled aggregates. So, but they perform different functions. So a natural aggregate will perform a function for structural heavy-duty concrete, which is real structural elements in buildings or roads or bridges, whereas a recycled aggregate's only ever going to be used in a bulk fill application, drainage or utility. So I don't know if I've gone off topic there, but that's
that's good.
Slate summary.
So what would you say is the main source for C&D waste in the UK? Is it soils, or is it debris from demolition jobs? What's the main source of the feed material?
Well, listen, I think I think it falls if you. It's easier to understand if you take the different character or the different definitions of each element. So you've got inert waste. So you've got three waste categories. So you've got inert waste, which is basically waste that will not change form, well, no matter what you look at it. Then you've got a non-hazardous waste, and then you've got hazardous waste. So each of those three waste streams have a different home from where their actual waste was produced from, right? So the stuff that we're generally looking at in C&D recycling or recycled aggregate falls either in the inert waste primarily. That's a premier resource. So that comes from exactly what you say, bulk excavation waste. So somebody's digging a new road, or maybe very clean C&D material that's coming from a construction site. Those are the kind of two main areas. Then you get into slight more specific waste, like non-haz waste. So maybe stuff in the like a 1912 waste code, which is like Trommel fines, or it's Mur code 1912-11, which would be in a hazardous form of that. So generally, most of the work that people are trying to look at is bulk excavation, inert waste into their stream, because it's the easiest handled. Once you start to get into dirtier skip waste, it actually causes further mechanical processes, a lot more capital expenditure used to actually deal with that waste, and then can lead to a lot more permanent problems if you're dealing with environment dates, you know.
Sorry.
Is it
Well,
the
no,
same? Like, is it the same in America? Or what is it? I know your road construction is a lot different to us. Like we would use a lot of asphalt, and you would use a lot of concrete. You know.
So I would say in the North American market, C&D Recycle has been around maybe 50, 60 years now at this point. And it was predominantly dry processing, so crushing and screening, crushed concrete, asphalt. Um, Wet processing has really moved in probably in the last 5 to 10 years. And there isn't a lot of customers right now that do C&D Recycle wet processing, but
Right.
definitely it's going to increase for different reasons. It's driven, first of all, by the market. So there's certain areas of North America where virgin materials is just not present anymore. If you think of like Long Island and New York, there's virtually no natural reserves left. So they're forced to recycle all of their materials. There's obviously areas in the US where that's not the case. You know, Georgia, Florida, Texas, there's an abundance of raw materials right now. So, but there's still recycle that goes on. Um, then there's also legislation which is driving people towards recycling. So there's money being granted through the Infrastructure Investment and Jobs Act. There's been money allocated to C&D recycling, so that's helping.
Sure.
Landfill is a huge problem. So we are more sustainably minded as a society right now, but isn't it ironic that we're generating more waste than ever
Yeah.
through construction of cities? We're expanding our infrastructures quicker than ever, I would say, in the last couple of years. And all that does, well, one of the side effects of that is we're just generating so much waste. So that has to go somewhere, and it can't all go to landfill. There's landfills that are just, they're at their capacity. So what do? Do we open up new landfills, and we're taking away that good land that could be used for, better projects and, digging holes and dumping materials inside it. So there's definitely incentives from various areas to C&D recycle. And I think there's definitely an education piece that's required. And hopefully this podcast helps with that. But there are a lot of uses from recycled aggregates. And, there's a preconception that recycled aggregates is not as good as virgin aggregates, which is not the case. Obviously, there's certain applications where you want to have good reserves, natural reserves for that. And as you touched on before in your comments, if you're putting a high-rise building or you're doing a bridge, you want to have natural aggregates that, provides strong structures. But there's a whole lot of construction projects out there that can benefit from recycled aggregates. And I don't think enough people realize that at this point. So hopefully this episode starts the education piece.
Because if you look over here, man, like 30% of all materials in UK used is recycled. Now, like that, like you have to be clear on that. Like that's regulation that's pushed that. You know, you can
Mm-hmm.
clearly chart from whenever the government increase a massive tax on certain waste streams and landfill taxes, then the use of those aggregates then steep up. So, like I like I know America's isn't a real like well they've obviously regulated in certain areas, but it doesn't strike me as an area that regulates and taxes that heavily. Is that right, man? Is it?
Well, it goes by state. I mean, California has passed regulations where by 2027, companies have to report their Tier 4 emissions, and which is very prohibitive. So basically, Tier 4 means that you have to report on the carbon emissions of your entire supply chain, including your customers. So you have to estimate how much carbon is being, transmitted to the atmosphere across the entire supply chain. I don't know how you do that. I just don't know how you do that. But that's the laws that are in play right now. And ESG credits, environmental social governance tax credits, basically are in play also. So if you can prove that you're lowering your carbon emissions, then there's a tax break. So we're seeing projects centered on C&D Recycle where ESG credits is a major motivation for companies. So maybe the customer has backing through stakeholders that want to prove they want to access the ESG credits, but they also want to prove their work towards lowering their carbon footprint to their customers and to their investors as well. So yeah, there's lots of different motivations. I think in time, it's just the interest in C&D Recycle is obviously just going to increase. I don't think we're going to go in the opposite direction. So it is an important topic. And there is, in terms of material streams here in North America, we're seeing a lot of excavated soils, both uncontaminated or inert, and contaminated. Contamination, including hydrocarbons, heavy metals, both suspended and soluble, and VOCs. So crushed demolition waste, so concrete, rubble. There's 7,000, between 6,000 and 7,000 ready-mix concrete facilities across the US, and they're all generating excess wet concrete waste.
Yeah.
There are ways to deal with that. If there's a high demand for those concrete blocks that you can make, like the Lego blocks, I call them, but you can only make so many of them or sell some of them. So we're actually looking at applications where we're breaking down that waste into its constituent materials, so sand and the rock and the water, and recycling those materials to put back into ready-mix concrete again.
Very good. Very good. And then the cementitious water.
Cementitious water, yeah. So before that goes back into the process for batching new concrete, there has to be a certain amount of pH adjustment. But yeah, there's a huge amount of waste being generated from ready-mix. So yeah, we're seeing results where we can recycle up to 100% of that material can be recycled back into ready-mix concrete, which can be used for structural applications.
Very good.
Hydrovac waste is a big thing over in North America. Hydrovac or hydro excavation slurry.
So that's only getting in here. That's only coming in here now. That really isn't a big. It's not a big thing with us.
Yeah, there's a lot of utilities that are buried underground in trenches without any piping around it. The cables are just laid in a trench, and they fill it up with some bedding, sand or rock, and fill it up with clay. So instead of a company coming in with an excavator to dig all of that material out to locate a utility cable, Hydrovac trucks go around and they spray pressurized water into these trenches, searching for the cables, and then they suck up that clay and the rock at the same time, and the water at the same time. So the feed material is very wet. Sorry?
So the trucks come back with water, sand, stone, grass, soil, everything in it. I've heard.
Yeah, anything that's just sucked up from underground. So the the hose on those Hydrovac trucks are typically 8-inch diameter. It's neck down to 6-inch. So, I mean, you could have 3 to 4-inch material coming into a Hydrovac facility. The challenge with that material, it's very wet. It's probably 30% solids, 35% solids. So you're trying to make use of gravity to feed that slurry into, a receiving hopper that, feeds the rest of the plant. But that material can be recycled to make a sand and a rock that can be reused in construction projects. The real challenge with that material is the high clay content, as you can imagine. With all that soil. So the tailings management is a little bit trickier. You have to just deal with a lot of clay. But I would say, railway ballast obviously is another big one here in North America, and you might get some odd projects where with Trommel fines and that, but I would say mostly it's excavated soils, C&D debris, Hydrovac waste slurry, and concrete ready mix.
Yeah, so we could see there's certain companies doing it over here, but you definitely could see an area where that's going to grow, especially like say for example you're an excavation company and you knock out a power grid or something, the fines must be astronomical. So I can see the benefit of doing hydro excavation waste over here. Now, we don't. What do we? We don't we do there's a fair bit of railway ballast washing, but it's only really rinsing. Then you're dealing with obviously the hydrocarbons and pesticides and cleaning up the bacteria that's there. Maybe a bit of pH correction of the water. But again, there's so much aggregate here, probably similar your trap or basalt that you're actually using just as a relay. But probably the biggest thing that we see right now trend in the UK is Trommel fines. So that's turning into you could feel it brewing in the marketplace. It's turning into one of those areas where it's just nobody wants to touch it. Because if you think about it before, they go from a standard rate tax this year, I think it's gone up to £4 a tonne. And then the next band up, so that's inert waste, the next band up to the non-haz waste goes up to maybe 107. Don't quote me on that figure, but it's around that figure. So what's happening?
Sorry, what are these figures, Donal? This is that's landfill tipping fees.
That's the tax rate, right? So those two figures is really the opportunity gain for people that can actually get a material from inert or from non-hazard to inert, right? But Trommel fines, what happened with Trommel fines is that they want to, 2015, they brought in this loss of ignition test where they take a sample, they burn it, and then they weigh it. Way before burn it, they weigh it after, and as long as it was there was less than 10% of that constituent part that didn't burn, then it was fine for inert waste. But what they're finding is that waste, there's so much more other contaminants in that, just bar stuff that can burn. So what's happened is that they're trying to reclassify the legislation in a way that is actually more in line with what the actual material is. But now what the challenge you have is that the risk now lies with the landfill operator, right? So if a landfill operator takes in the material that a producer says is inert waste, and then that gets tested, say there's a subsequent test by either HMRC, and they find that waste actually should have been classified as non-haz, then the landfill operator is actually liable for all that material at the rate adjustment plus a fine. So then what they're actually saying now is that they're going, well, the landfill operator is saying, hey, do you want to know what? I'm not going to take that waste anymore. I don't care if you tell me it's inert waste. I'm either going to charge you it at the higher rate, or I'm just not going to take it, because you can't get a landfill in the UK. They have a certain level of void space. So then what we're seeing probably towards the middle of last year, and obviously ending now, is that there is going to be a massive demand to be able to process that Trommel fines and bring it down into a stream that's actually inert, that actually can actually be sold back into the marketplace, because there's no landfill operator is going to want it. So it's interesting, and that I'm not going about it too much, but Trommel fines was actually skip waste, right? So they would take it with material handlers, they would grab it and go into a belt feed hopper. And the reason why they call it Trommel fines, that would get conveyed up and empty a Trommel barrel, which would start turning the material down. And all they were trying to do was take that fine material out before the further process was like picking. So you had people in like a picking station pulling out like sticks and plastic and different constituent parts that would actually get segregated and sold out. But what they found was that they actually started increasing the technology to actually bring that Trommel fine material down from 40 down to 10 mil. So they're actually able to pick more of the product out. And it actually doesn't go through a Trommel anymore. It goes through like a flip flow screen that can deal with like, wet material. So their material comes, grabs, seam at the belt feed hopper up in the main feed conveyor, but it goes over a flip flow screen that's flopping the material and pulling like a 10 mil fine material out. So then what happened is all they've done is chase that contamination finer and finer and finer. And now they're left with this material that is pure and utter garbage, and nobody wants it. So the only way to treat it now is wet processing. So, and then that provides huge challenges for somebody that wants to wet process it. So it's an interesting time now with us over here.
So whenever you wet process Trommel fines, what size of material then are you processing? Is it 10 millimeter minus material, or is it larger than that?
So if most of the Trommel fines in the UK, once it's been through a mechanical process from a skip company, is generally coming in at minus 10 down, right? But what you find is that that's not really sustainable for just making a wet wash plant or wet processing system. So what they'll generally do is they'll take Trommel fines from one location, and then they'll take like a C&D, bulk fill excavation, construction demolition waste in from another, and they'll blend them and add them into the system, So that's generally what's kind of happening. So the challenges you find with it is probably exactly what you said before at the start, man, when you've got like heavy metal contamination, either soluble or not. You've got like pH correction, adds huge contamination to the water. So you've got pH correction. You've got a trash element, either a huge trash element at that 10 mil that can either go on through a log washer, attrition scrubbing unit of some sort. You have to deal with that. And that causes a problem because, like, say you've got a glass of water here, nearly right, and then you add like a bit of like plastic or a bit of paper to that. What that's doing is that's acting like a heavy. So that's sinking to the bottom of your glass, right? And then or sinking to the bottom of the glass in that scenario. And that's really acting like a heavy, like an aggregate. So you have to start designing your system to deal with a light fraction that's actually acting like a heavy. So that's the interesting thing about Trommel fines. And then probably finally, once you've actually processed the material, and you've kind of sized it through its constituent parts through wet processing, you're actually starting to see a lot of organic fraction in the sand, along with cementitious bits and polystyrene balls. So there's it's interesting here at the minute with it.
Yeah, it sounds a lot like the applications we're working on right now in terms of contaminated soils. So we design a system based between like an average feed and the worst case feed gradation, but we also have a good idea of the types of contamination that's going to be in there. And like density separation is really, our systems will have that included in them, because you're going to have styrofoam or polystyrene plastics that all have to be removed from the sand fraction. So, and sieve bends to capture those contaminants.
You're doing upper current. So instead of doing a classification through a cyclone, you're doing an upper flow classification through.
Yeah. If there's a good difference in specific gravity between the contaminants and the aggregates,
okay.
Typically we're looking for like 1G difference. We will add a hindered settling classification unit. So we have, you could use a flat bottom classifier paired with a sieve bend, and that introduces a rising current of water, which will float out those organics. Or we also have the hydrosizer. The hydrosizer has been used a lot for glass sands and frac sands. It's probably the gold standard when it comes to, that classification. So either works for removing lightweight contaminants in C&D Recycle, but it has to be paired with the right equipment as well. So a flat bottom classifier and the hydrosizer, they're fed. Typically, they would be fed with a cyclone if it was a natural sand and gravel application. But what you find with soils or C&D recycle, the feed material varies so much, and the swing between coarse rock and fine rock swings, bucket by bucket. And we have better results actually by swapping out a hydrocyclone with a cyclone separator.
Yeah, it makes sense.
So the cyclone separator is a variation of the hydrocyclone, which has a modified overflow pipe and works on the concept of adding a siphon to remove the fines from the cyclone. So it actually doesn't care if there's swings in solids concentrations in the feed coming into the cyclone. It's still going to make the same cut at the bottom end. It's going to discharge, a relatively dry underflow. With the hydrocyclones, if there's swings in that feed, the hydrocyclone will begin to flush if there's a drop in the solids, or it might start to rope if it's being overfed.
Yeah.
And that will upset any downstream processes that's moisture sensitive. For example, a flat bottom classifier or hydrosizer. So I think what we've found over the last number of years dealing with this applications is there's a lot of pieces of equipment that is used in natural aggregate processing, but also in the mining industry, which we can apply to C&D recycle. So for some of the suspended contaminants like the heavy metals, there's mechanical means of separation by using technology that we have applied in the past in the mining industry. So I think some people get scared when they talk about processing C&D recycle. To be honest, it's not a black art. To me, C&D is just challenging and deleterious. And I mean, we do that type of application in a natural sense every day.
Yeah. But I think you find like people, like the reason why they're scared is because it's the first time they've done it. It's the same with everybody. Like it's the first time you do it, you're going to be scared. Like generally, most of the plants and a lot of the time spent talking to customers about these products, or customers that and they could be quarry operators that have been dealing with blasted rock for 30 or maybe generations. But once they talk about inert waste or bulk excavation, they get so nervous about it.
Yeah. So could you walk me through a little bit more about a typical soil wash plant that you would see in the UK? What from the material coming in, would some of that material be crushed, or would it be segregated, or what way do they prep the material before they start feeding the wash plant?
Well, listen, there's two. As far as processing the waste that comes in, every producer follows near the same blueprint, right? They start off doing dry crushing and screening, as what you said. So if they're doing recycled asphalt planings, they're using a horizontal impactor. Material comes in at probably 26, 28 mil, or maybe bigger clump sizes, and then they're crushing it down as fine as they can. They re-add into an asphalt plant, or they're taking in C&D bulk excavation waste, and they start it through like a jaw crusher. So they're taking that maybe 300 millimeter material. Sorry, I'm talking millimeters. I have no notion what your sizes are in America. So I'm going to start.
You're good. You're good.
So they take that material in, and then it goes through a jaw crusher, and then they crush it down to like 100 mil down, 4-inch, and then that becomes what we classify as 6F2. So they would get like a product price for that, Neil. So say they get 18, 19 pound a ton for that material. That's it done. So if they actually then want to actually get more value for material, what they then start to think about is wet processing. So as far as sorting materials before it, again, it can go through a jaw to bring it down to a certain size, or in most cases, it's a 50-50. It goes through like a tipping grid at 4-inch down, and do like just a belt feed hopper that regulates the feed on the main feed conveyor, or it comes into a scalping screen, which is primarily designed to take a large lump size and pull as much fine material away as possible. So then the oversize, which is generally in the top size of that grid's maybe 75 millimeter, all the oversize is then only ground clean, which is put through a jaw crusher and fed back into the plant. Mm-hmm. So the undersize then is fed up into a screen, which has got spray bars on it. generally what you're trying to do there is you're trying to flush all the fine material down into a sump, which is you've basically got all the slurry, soil, effluent, any kind of sub 5-6 millimeter material goes into a sump. All the oversize or all the size bigger than 5 mil is generally making its way because it's really clay bound or heavily mixed with maybe further contamination. It either goes into it'll definitely go into some form of attrition scrubbing. So in McLennan, we've got a fairly wide basket in that way, but generally what we see in North America is the product that was obviously invented by McLennan. The log washer takes that, provides the hard attrition scrubbing to break the clay balls, and then pulls the aggregate forward before it's sized in the aggregate. So the size of aggregates we have here is 10, 20, and 40 mil. They're generally sized after the log washer and stockpile the ground, ready to sell out to the customer marketplace. The sand and the effluent mix that was in the sumps pumped up, and generally anti-cyclones. Now we have areas exactly where we're talking about separators, which provides a real unique selling point in what we're talking about. But generally, what you see over here in the UK is hydrocyclones. Generally, obviously, dewatering the sand and stockpiling it into all the dewatering screens and then stockpiling it the ground. But we're probably slightly different in scale here, man. Like our plants are probably 100, 120 ton an hour on average, you know. Like we wouldn't see many bigger than 200. Like we find once you start to get over 200 ton an hour C&D, it starts to get really prohibitive. And the tailings management solution, I don't know, is that the same in your end? Is that the same scale or?
Most, I would say most applications we're coming across is 150 or 300 tons per hour
Yeah.
feed material coming in terms of soils. But again, it's somewhat, you know, it's just, you walked it through really well there. It's the same process. Usually, if the material is going to be sticky, clay-bound material, it goes into an apron feeder onto a scalper, and then that 4-inch minus or 3-inch minus passes through onto a conveyor belt. And then we obviously add in the magnets to pull out some of the ferrous materials from that feed stream. You're not going to get all of it out because, you know, some of that material, some of that metal is just going to be buried. But we're trying to just protect the log washer with that magnet and try to pull out as much steel as possible so it doesn't cause problems downstream.
We're starting to see some eddy current separators being added into the plants as well, you know, trying to remove ferrous and non-ferrous material as well. Do you want to talk about, I only brought it up to the processing part, do you want to talk about the tailings management maybe, you know, after the overflows of cyclones or separators or?
Yeah. So like the dirty, the wastewater from the cyclone or separator overflows gets transferred to the thickener. There's different styles of thickeners available. High rate thickeners, high density thickeners. The high density they're very similar in appearance to the high rate. They have taller sidewalls, and that just provides increased residence time. The tailings management is, to me, it's the critical part of the design for any C&D recycle facility because it's really if it's undersized, then it's very prohibitive for the customer to run the plant. So we're generally very conservative. I mean, we do lab test work at our facility using representative samples for every project, but we're very conservative in terms of how we size our thickeners because if that becomes the bottleneck, or if the filter press becomes the bottleneck, then the customer is not going to be able to wash aggregates anymore. So we add in plenty of room in terms of capacity for the thickeners. The thickeners is basically a sedimentation device. It uses surface area, gravity, time, and polyacrylamide flocculants to settle out fines that's in that wastewater stream and drop it into the bottom of the tank. So it's basically a thickened mud at that point. And the water that's clarified rises through that tank and overflows a peripheral weir, where then it's diverted to a water tank that can be reused across the plant. There's certain things that we can add to the thickener to assist with, optimal performance with the flocks. like automated autoflux system, which it measures the attenuation of light within the feed well, and that sends a signal to the polymer dosing system to either turn up or turn down or slow down. The more controls that we add into your thickeners, the more the operator can see, and he can control that variation in the material coming through. But
you're 100% right. Like we see, like you wouldn't believe the many plants. I think this is when you talked at the start about dark arts. This is the one that just is the area where I think the customers are served wrong. Like they don't get told the calculations behind designing thickeners. They don't get told calculations behind how we're sizing filter presses. Like we do, but I think the marketplace as a whole doesn't get that. So like there's so many, like I could take you to so many plants in the UK that have been completely undersized. Customer plants maybe be sized at 100 ton an hour, but they can only run 30 ton an hour because either the thickener's not designed the right size or the mechanical solution after that, either a centrifuge or filter press isn't done right,
Yeah.
Do you want to talk about the filter press, Dave?
Yeah, sure. And like
mechanic.
some of the controls that you put in place is basically common sense too. So you need to understand what type of material that you're feeding into the plant. So if you're feeding material that's 40% silts or clays, that's going to be a big no-no. It's going to be put a huge burden on your thickener and your filter press, and it's going to slow down your operation. So to me, it comes down to a bit of common sense planning. Try and feed that wash plant in campaigns. So basically, if you have, generally you're going to need more area for incoming feed materials so that you can segregate it and you kind of understand how each material stream runs through your plant, or how your wash plant responds to that material stream.
Okay.
So if you can run the wash plant with one campaign of material and understand how it responds, I think that's going to give you more of a consistent product at the end. But in terms of the filter press, from the thickener underflow, that mud will be pumped to a steel buffer tank, which holds that mud. So the thickener is working on a continuous process. It's trying to float out the clarified water and sink that mud as quickly as possible. And then once a certain bed level of mud is inside that tank, the pump will turn on and pumps that mud into a holding tank, a buffer tank. And we need that because the filter press downstream works on a batch cycle. So you have a continuous process with a thickener, you have a batch process with a filter press. You need something in between to act as a buffer, basically a mixing tank. Now, what we're seeing in North America is you could go down the route with steel tanks, or you could design a bigger concrete tank, and that just provides more buffer capacity. So we're seeing more and more of that with our soils wash plants.
Because I suppose the concrete tank provides a structural element too for the filter press as well.
Exactly, and the water tank as well. So yeah, now you will require probably more mixers to keep everything fluid inside a rectangular tank as opposed to a cylindrical steel tank, but it provides that increased buffer, which is important because, as I said, if you're dealing with really bad material, that's going to cause a bottleneck. So if you have a larger buffer tank, that will help. Now the filter press is sized. We can size the filter press based on the customer's data. There's different sizes of filter presses out there. 2 meter by 2 meter is what most people will use. We do have a 2.5 meter by 2.5 meter, but
you're showing your size again here, man. We look at America's always bigger, aren't they? These are always bigger.
Yeah, well,
ours are 1.5. Well,
the 2.5. Yeah, the 2.5 isn't really used.
3 meter if you get away with it.
Oh, I would sell 4 meter, Donal. The 2.5 is more for the mining industry. However, it's not to say it could obviously be used, but the 2 meter by 2 meter by 220 plate is generally the accepted size for about 250 ton per hour soil wash plants.
Yeah.
Now, following some test work, we can calculate the cycle times required to turn that fluidized mud from a thickener into a dried cake. And talking with the customers, we try to understand, well, how many hours do you run the wash plant per day, and how many hours can you run the filter press per day? Because what you're going to find out is if you're generating more mud with your wash plant than your filter press can handle per hour, you want the filter press to run an additional 3 or 4 hours per day if possible. Sometimes that's not possible, and then it's a case of, well, if you have a large enough concrete buffer tank, come in on a Saturday, just run the filter press and try and lower the levels inside that buffer tank.
So you're talking about outside hours of pressing then. So run for 10 hours and press for 16.
Yes. So it's all about just making sure that the wash plant can run whenever the customer wants it to run. You don't want to be in the situation where we can't run the wash plant because our buffer tank can't take any more mud. I mean, that's just the worst case scenario, especially when you're 5 or 6 guys employed and they can't run the wash plant. So we're always just trying to design to provide the customer as much control as possible. Sometimes that requires more additional upfront costs, but in the long term, that's going to save a lot of money and increase their uptime. So, and then we also have, we also look at centrifuges, decanter centrifuges. There are material streams with C&D that doesn't lend itself well to filter presses and Hydrovac waste, which I know is not that common yet, but whenever there are applications arising in the UK, it's really because it's such a clay-bound material. The cycle times with a filter press are quite long to try and get a dewatered cake, and it's just made for that application. Is just made for a centrifuge all day long. So the way they're so good with Hydrovac waste material, if you can think of clay material. Clay is basically like 2-dimensional. They're like potato skins.
Yes.
And they're very hard. It's very hard for water to pass through that, those like potato skins. So with the filter press has a really hard time to squeeze that water past those clay particles through the cloths. The centrifuge is more of a fluid. Well, it's a moving piece of equipment, and it just flings the material, around in circles at a very high speed, and that helps to like generate, push the water out of the decanter centrifuge bowl.
Very good.
And most applications, certainly the filter press, but we found with, applications and test work, we get much better results with centrifuges whenever they're applied to Hydrovac waste. So, but look, it's just looking at every single application for its merits, understanding all of the facts, getting the operating conditions from the customer, and designing a solution that that they need based on their budget too, that's available.
And products the same, sand, 3 or 4 grades of aggregate, or is there products that they?
It's usually 2 sands. Usually 2 sands. So we have the density separation system in play on the sand side of the system. So as a result, you're generating 2 sands. So a coarse and a fine sand. And the finer sand, it's really a non-spec product. Maybe there's applications for like pipe bedding, things like that could be used for. But what we do is we take a portion of that fine sand and blend it in with the coarse fraction, so that we have more of a concrete spec sand out of it. So, but with C&D Recycle, anything that's between 5 millimeters and 75 micron will be in there. If it's similar specific gravity. So you're going to have bits of brick and concrete and sand and gravel mixed together. So whenever the feed coming in is so variable like that, it's, that sand can be used for construction projects, which is not, probably not as critical or load bearing. If you're trying to make a high quality ready mix concrete sand out of it, you have to be very specific about the material that you're feeding in. So, ready mix concrete, which is dried out and crushed and run through the wash plant, I mean, that's a pretty, reliable, consistent material that that you're going to get coming out. So that's why I'm sort of saying that if you can run the material in campaigns, what type of products you're going to get out of it. much if you're targeting a specific, high quality product at the end. So just to circle back, Donal, I just wanted to talk about the commercial considerations for C&D recycling. And what we're seeing in the US, obviously, there's a demand for modernized infrastructure, to support growing populations, and there's been money allocated in various ways from a federal level for that. But there's also, demand from sustainably minded customers, investors that want to prove their actions towards achieving, call it net zero or call it more sustainable results, call it what you will, but there's certainly a growing demand from customers that want to prove that they're going in the right direction. But what we're also seeing here also is there's increased costs with mining and particularly with hauling and disposal of aggregates. So, as reserves deplete and as construction expands, to wider rings from the center of activity, the hauling distances have increased, and the cost of gasoline and diesel is really increasing as well. So the cost to move materials is as I would say, the key driving factor from a commercial point of view. By trying to minimize the distance from taking recycled aggregates or raw aggregates into a building site, or taking that disposal material, that demolition material from the site to a landfill or to a recycling facility. That's where it makes a lot of sense for people in North America. But it's all about finding a good location where you're located close to a larger city, and if you can exploit that distance and savings and transportation costs.
Because see if you look at a map of the UK, right, and you take London down in the southeast, it has no resources, right? So it's actually there's barging material from Scotland or barging material from Cornwall. So we have a plant down with a company called Goodbean Aggregates down in Cornwall, and they're producing it's like overburden scalpings from a secondary process, so a kind of clay mine. And once that material is processed, that heavy burden material is processed, a lot of that material from Cornwall is getting shipped into London because they've got no aggregate. So like the commercialization of these plants make absolute sense. If you see when I talk to planners or mineral planners over in the UK, they talk about 15, 20 years ago, whenever say you had a mineral producer that was trying to get planning for a new site, right? They would be saying to the end seekers, would you not put on a waste permit in that as well, so you can deal with excavated soils or inert waste? And it was nearly a fight. Whereas now, see this co-location of sites as a must in all planning. So when you've got a site that's actually can produce minerals, but that site then can actually produce recycled aggregate as well. It's not even talked about anymore. It's just such a standard over here. So and as well as that, probably a big thing. If you take a mineral, right? So say you're taking a granite, or you're taking a basalt, or you're taking a limestone or gritstone or whatever, you're paying to blast that rock. So you're stripping that rock, then you're exploding it, you're blasting it, you're hauling it, you're crushing it. Whereas recycled aggregates, you're getting paid. So you're getting paid to bring that in. So some man's producing that material, he's hauled it into your site and paying you to take it off him, and then you're processing, and then you're getting paid to sell it back out again. So as far as a commercial point of view, from a processor that's maybe thinking about doing it, it's a no-brainer.
Yeah. There's also guys that are running it.
Go ahead, Nate.
Sorry, go ahead.
I also too, from a planning point of view, if you want to get a new plan, I don't know what's in America, right? But it could take you 10, 12, 13 years in order to get planning for a mineral reserve. Whereas if you've got an old site that has already got access to highways, that's ready, the environmental impact of that site's going to be minimal, and it's ready sitting there, you're going to get past from a planning perspective and a permanent perspective a lot quicker than you are a brand new mineral reserve.
Absolutely, yeah. It's much easier to get grandfathered in, looking for a new site.
But then, I mean, go ahead.
There's also the guys, that have been processing materials, and they're just running out of reserves now. And they have a team of employees that they're trying to keep employed, and they're trying to keep their doors open. So if they don't have the raw materials, the virgin aggregates, what do? The recycled aggregates becomes very attractive as well.
Those, especially those guys that have, like, say for example, you operate like an inert landfill site, right, Neil? So me and you operate an inert landfill site, and we've got a site that's got a void space of 2 million ton, right? And you think to yourself, right, I can take in 250,000 ton a year. But imagine if that 250,000 ton a year, I can actually recover 80% of it. Or you see 60% of it, and you recover that 60%, and then you sell that back out. So you're only actually dumping 40% of the material back into your landfill. So you're increasing the longevity of your business as well. So like it makes absolute sense, from a commercial point of view.
There's contractors too, and it might be more difficult to get permitting for sites if they don't already have one, but there's contractors that have access to the materials every day because they're hauling that material. And it might be a nice alternative revenue stream for them if they take that material and process it, and sell it again. But again, the challenge is permits and getting somewhere to have that facility in place.
Well, I don't know what, like, now the planning and permitting over here is slightly different. Like, we've got a planning for mineral reserve halt, like, actually probably similar, because you were saying about states. Over here, it's by county to county basis, they decide it. But then we've got the Environment Agency that handles out all the permits as well, in order to be able to accept what type of waste stream you're allowed to accept. There's off-the-shelf permits. So you can get like an off-the-shelf permit in order to process material pretty quick. So like it's just like it's a completely interesting marketplace. And I would say Ireland's now completely different. Ireland's like Ireland has actually only passed as of the back end of last year, I think, they passed the paper at the end of 2023, but they're only starting to allow recycled aggregates back into the construction space now. So they only ever had like maybe 2 or 3% of all aggregates used in the construction was recycled, and that's basically because like there was a huge amount of resources in Ireland, so there wasn't a real need. But now they're starting to delve their toe into it. So Ireland's probably the same place that North America is in its journey. But it's an interesting journey.
So what about the environmental considerations in terms of landfill? So one of the drivers for us is methane emissions associated with landfilling. So methane would be 84 times more potent than carbon dioxide. So it exacerbates a lot of problems. So yeah, trying to minimize that landfilling is really important for us from an environmental point of view. And again, as I said before, we're generating more waste than we ever did with the increasing in construction projects. So something has to be done. Otherwise, there's going to be landfill sites everywhere, which nobody wants.
No, definitely not. Listen, it's the same over here. It's like, well, we don't have access to a huge amount of landfill, so you're trying to conserve landfill space. You're basically trying to conserve, or you're trying to maximize the landfill space you have. You're trying to like conserve the natural resources that are there in the marketplace. Obviously, the net zero and carbon emissions is a massive thing over here in the UK. There's targets of that. There was targets of completely net zero by 2030, but they've pushed that out. But like, there's a real drive towards sustainable construction practices here in the UK. So, and recycled aggregate, it forms a massive part of that.
Yeah, there's also the avoidance of any long-term liabilities, associated with landfilling materials. So I can see that being a big driver, especially over here. Perhaps lawsuits would come into play if there's more and more landfills.
Like, are you thinking about leaching?
Yeah, you think about wildlife. So many people, so many things will be affected by that. So, but yeah, so it's there's commercial considerations, there's environmental considerations, which it all points to everyone sort of exploring or, taking on the opportunity to do some C&D recycling going forward. So, but I think we can wrap it up at this point, Donal. I want to thank you very much for joining us today. I know it's later in the evening where you are than it is over here in North America. So
it was a great conversation, Neil. Thanks for having me. We obviously went over the definitions of what recycled aggregate are and their importance to the marketplace. We talked about the growth and the global growth in recycled aggregates and their uses within the marketplace. Obviously, there's differences in each region. So there's differences in the UK and Ireland compared to where you're at in North America. We kind of went into the planning and permitting of each of those resources, and then you eloquently talked about the processing and all of that waste and what McLaren products are used. So that was kind of from my side.
I wouldn't say it was eloquent. The viewers may have to have subtitles particularly for me in this, but hopefully not. But yeah, and to your point about different regions, so McLanahan's well placed to help customers wherever they are. Obviously, your team based in Northern Ireland, McLanahan's very well established here in North America. We also have teams in Australia and South America and Asia. So it doesn't matter really where the project is regionally. We have local teams there that can look at each application. And having said all of that, we're one group, and we feed off each other. We learn from each other, and I think one of the strengths that McLanahan has is just the depth of knowledge that people have over
100%.
over the years, and whether it's mining or agriculture or C&D recycling, or there's lots of expertise there, and we're able to draw off each other and draw off the equipment that we have. And I think one of the benefits too is we take an unbiased approach to any application. I think in certain ways there's been an industry acceptance of how things are done, but I think we take a different view. We look for the best results that we can achieve and try and explain that to the customer. But local support too with dealer networks is very important, and McLanahan has strong dealers globally, so I think that helps us all. So thank you again, and appreciate your input and time, and good luck with 2025.
You too, man. Thanks for having me.
Thank you for listening to Groundwork and McLanahan Podcast. Be sure to follow us on social media for updates and more content. See you next time.